So my name is Jochen, I work at NVIDIA, and today I would like to present a little bit about agentic AI platforms and how we can leverage them to innovate and to automate, right? So making things faster, less expensive, but also to build new products, right? So obviously, agentic AI is not only a buzzword, right? It's really changing, from our point of view, the way we work in the future. Think about all these knowledge workers around the globe that will now be able to tap into databases, collect huge amount of data, and improve their knowledge work, improve their research. Or all the software developers that will change the way they produce software in the future, leveraging AI and agentic AI in the background, and so on, right? Call center agents that can more focus on the customers, while in the background there are agents that sort of record what they are doing and help them ad hoc, right? So it's a huge market, and it will change the way we will work. Agentic AI, according to IDC and others, it's going to be a game changer. 50% of the organizations will use the agents to achieve faster business value from AI. Already this year, 33% of enterprise software applications will include agentic AI by 2028. So it's a large transformation going on, and it will help us gain better performance, solve problems, and accelerate products, time to market, and these things. So how does an AI agent actually work? So AI agents, they have access to tools, they have access to technology, they think, reasoning, right? We heard about DeepSeek models. And they have access to the compute power, to tools, and obviously also to other agents. There can be a communication, agent to agent, human to agent. So think about agentic AI as sort of an enhanced IT department. That's the HR2 department, right? Obviously, the HR department has a great platform in banks, for example, to manage all the employees, the human employees. Now the IT department also needs equivalent platform to manage all the digital employees, right? There will be thousands of them, either used internally in banks and financial service organizations, and also financial service customers will have access to their financial agents 24/7. So there will be a lot of agentic AI, a lot of digital employees that collaborate with other digital employees and collaborate with the human employees. So it's HR2 is the IT department, right? So these agents need to be onboarded, they need to be educated, they need to be guardrailed, they need to get instructions how to collaborate with each other, right? So it's quite similar to what we already know, but now we have autonomous agents that help us. Think about software production, for example. Just to give an example of special agents, how they would automate our work. So we obviously need an orchestration agent who accept prompts and instructions where we teach the system what kind of software we want to build. And that orchestration agent has access to other special agents. In this case, there's one agent that's very good at bug tracking. Another one is doing the tech documentation while you produce the software, and the third one can execute the coding. So those are interacting, and the orchestration agent sort of orchestrates. This is a very simple example, but obviously we can build very complex agentic workflows in the future where many small models are involved, where many microservices are running. So I will later on discuss how we can orchestrate entire agentic AI systems and how to build platforms that are able to manage and run and orchestrate and optimize these agentic systems. Yeah, as I mentioned, it's very complex to build them, so we need to think about architecture. We need to think about repeatability and code reuse. The performance is very important. We can't afford to have agentic systems that take very long with their responses. We want interaction, right? Because they are here to support real employees, human employees. Safety, security, privacy, enterprise readiness, user AI interaction, all these topics. So it's going to be a very complex task to integrate all these heterogeneous data sets and perform agentic systems in a very reliable way, which is obviously very important in regulated industries specifically. So just to have a look at history in terms of AI journey that we are on. So obviously we had the perceptive AI detecting patterns. Then we had the ChatGPT moment, the generative AI generating answers. So those were more single applications, single use cases everybody was talking about. Where can we use AI? What are the use cases? Where is sort of a predictive model? Where is a generative AI model? Now we have a very different kind of development. We have an era where we can generate outcomes with agentic AI, and we see that we need sort of an AI factory. That means an AI infrastructure, a full stack platform that is able to create these agents and run these agents at massive scale. So AI factories, I will briefly talk about it, what that is, because that is the backbone of our agentic systems. So AI factories is something that emerges now in many industries, not only financial services, also industry, healthcare. It's basically like a factory that you can imagine that has input, which is data and energy. That's the input. And the output is tokens or units of intelligence. Right, so that's the output, and those AI factories, they can reside in public clouds, but they can also reside on-prem or in sovereign clouds. You may have heard the news like 2 weeks ago when our founder and CEO Jensen visited the Starmer and Macron and Merz, right, talking about sovereignty of Europe and how to build these gigafactories in Europe. So that's exactly what's happening now, is that people are building their regional AI factories or building out their AI factories in the public cloud. It doesn't actually matter. What you need here is basically accelerated computing and software stacks that's what you need to build these factories, really. And they are the backbone for agentic AI. So what you need in an AI factory is obviously a foundational model, for example, a Llama or a Mistral or other open source models or a DeepSeek. Then it would be about your own data. Corporate owned data is a very valuable source because no other corporation has access to it, right? So we need to activate all this data using agentic AI, generative AI, and we need a bunch of tools to fulfill that. And it's different tasks that an AI factory is doing. It's obviously running the agentic systems, so that's the inference platform. Obviously, large models need a lot of compute during the runtime to be responsive, to have low latency, to have many users that are served. But also we need to sort of fine-tune these models because the out-of-the-box foundation models need to be adapted, fine-tuned, customized, connected to corporate data to create value, to create specific applications. And that's also something that the AI factory is doing. It used a lot of compute to build these retrieval-augmented generation pipelines to customize and fine-tune models and many other tasks, including monitoring the agents. That all these things are very compute intense, including the reasoning models. Reasoning models just means that these models think longer than just the one-shot models like a foundational Llama or Mistral. When you use it, there is an immediate response. If you look at a DeepSeek reasoning model, this model starts thinking, reasoning, and then comes back with an answer, even using more compute. We call it the test time scaling or third law of AI scaling. So some media had stories around that these DeepSeek reasoning models would actually reduce the amount of compute, but it's actually the other way around. Those models are small and efficient, but needs more compute to think. Yeah? And thinking agents, that's something that we need to build successful agentic AI applications. Why is accelerated computing so important building these AI factories? It's not possible to just use a conventional data center to build these factories. There need to be specific factories, AI factories that have specific technology underneath, namely accelerators. So the traditional data centers are powered with CPUs that we have in our notebooks and laptops, which are fine, but they are for AI jobs not the right, let's say, equipment. So when you offload massively parallel workloads from CPU to GPU, you will see these kind of acceleration factors. So this is an example. You have a task that takes like 101 time units, could be an hour or seconds, whatever. And it could be a workload like processing huge amount of files, customizing a model, running a model, monitoring, putting guardrails around a model. All this is compute intense, and you have the choice between accelerated computing and not accelerated computing. So what happens when you add the GPU, the graphics processing unit, to the CPU? It can do all these jobs much faster and quicker. First of all, when you add such a chip, there's more power consumption and there's more cost. But what you get also is you get the workload done in like 1 hour or 1 second versus 100. And these acceleration factors are not uncommon. Yeah? So if you do the simple math, you will see that it's a cost saving of 98% and an energy reduction of 97%. So that's what's happening when accelerated computing comes into the game. So I wanted to show you that it's really crucial to think about AI factories at scale that have these efficiencies. Otherwise, we will not be able to run agentic systems with thousands of agents. So we need to think about using small models and efficient compute to be able to run all these agents. So now talking a little bit about the software and the models that run on top of the factory. So building agentic AI requires advanced models. We need highly accurate models that can do very specific tasks in agentic, because we have special agents, right? Need to be commercially viable, so we need full control to integrate in enterprise applications and to be able to run everywhere, because we need to have the choice. As a bank, for example, do I want to run this model on premises where my data is super safe and secure, or is it okay to run in the public cloud? Or is it okay, or is it better to run my models in a sovereign AI factory, as UK and France and Germany and other European countries are now building them, right? Having the choice is really important, and open source models, because you own them, you self-host these models, you have the choice, right? So that's the foundation of sovereign AI, is to use open source models. You need to be able to customize those tools and models to fine-tune, for example, take a Llama or a Mistral model and teach it to become a financial analyst model or reading regulatory reportings. So fine-tuning customization tools to make these models more specific and accurate is really important to have good business outcomes. And as I mentioned before, we need to think about efficient computing. We need to minimize the cost of each of those agents, because we run multiple large language models. Otherwise, costs will explode and energy consumption too. And it's a good news, because the open source models are catching up. So here you see on the y-axis sort of an AI intelligence index for analytics. So this is, for those who know, it's a MMLU Pro. So it's one way to measure how many different tasks one model can accomplish. And these different tasks, that's important building agentic systems, right? One model documents the code, another writes the code, and a third model is doing the bug tracking, as we saw in the example. So we need good open source models that can execute all these different tasks. And also we need another model that orchestrates all these tasks, the orchestration agent, right? So we see here an increase of the sort of intelligence for analytics or different tasks of these open source models, obviously led by DeepSeek. And another new model family that I wanted to briefly touch upon, it's called Llama Nemotron. It's basically a Llama model that our engineering team at NVIDIA took, and we used customization tools to generate a reasoning model based on this Llama model. And we open sourced that, so everybody can do that now with the right tools and customize models and generate sort of reasoning models where you can switch on and off the reasoning. That's also an important factor because in many tasks, the reasoning is not needed. In some tasks, it's crucial. So when we are able to switch on and off the reasoning, we can save a lot of energy. What's the capital of UK? What's the capital of Paris? We don't need a reasoning model for that, right? Just to give you an example. So one of the key software projects at NVIDIA that we invested billions into this is called NIM, and that will let you run these open source models very efficiently. It's short for NVIDIA Inference Microservices, and what it simply does is it takes one of these open source models and put them in a container, as you can see here, and you have access to this container through API calls. So those of you who already use OpenAI, there's a specific standard to access model endpoints with APIs, so we use the same standard. So why invent a new standard? It's the standard accessing open models in general, but this time is a container that holds your own model, which you can deploy everywhere, in the public cloud, in the sovereign regional cloud, or on premises in your own data center and even in your workstation. Yeah, you only need GPUs underneath. And the next thing that these NIMs are capable of doing is you can swap in and out these models. So if you want to test a new model that's coming into the market, like a DeepSeek, or a new Llama 4 version, or a Mistral model from Paris, it needs 10 minutes to swap in and out. I'm not sure if you're aware how much time it takes for a developer to change one model to another in production, an open source model. If you don't have these tools, it takes 3 to 4 weeks. Versus here, it's like 10 minutes. So financial institutions can really concentrate on finding the right model that has the lowest hallucination rate, the highest quality, the best efficiency, and sort of profiting from all the new models coming into the market. So that's one of the ideas of NIM. Another idea is to accelerate the workload and make these models even more efficient. So here we have tested a Llama 3 8 billion model with the NIM software on and switched on and switched off, right? And we could accelerate the throughput of this model by a factor of 2.x. So that's really important metric because our AI factories should be measured by how much tokens or units of intelligence I can generate with a given amount of energy. We are a limited energy limit industry when we are switching to agentic AI, so it will be important to measure our AI factories in terms of how many tokens can we generate per second, how many tokens can we generate per energy unit. That's CEO math of the future, right? And the future is here. So it's important to think about these efficiencies, and we also tested other open source models like Falcon, Llama, Mistral, DeepSeek, and so forth. On average, we were able to get more throughput by 2x, 5x. So that's the range. And what's working behind, sort of under the hood, is some open source tools that NVIDIA developed. One of them is called TensorRT LLM, which is sort of doing quantization, so it can optimize your model, distill your model, make it smaller and compressed. And the other factor is a Tensor or Triton inference server. It's another open source project of us, which is optimizing the inferencing. Now it's called Dynamo because it can also handle reasoning models like DeepSeek and Llama Nemotron. So that's what's behind NIMs. It's other open source projects that we built and work with the ecosystem to improve the inferencing. Inferencing means running the model. Obviously, there's a lot of room for improvement and efficiency. Imagine you can have the same GPU and the same model, but you can generate 2.x more throughput, more users with the same resources. And that's also a great example showing why accelerated computing and the efficiency of AI factories not only depends on the hardware, the GPUs and the GPU networking, but also on the software stack and the tools to leverage the acceleration. So now talking about the reasoning, why do we need reasoning models in agentic AI? Because these models can better understand the context, can validate answers, can adapt dynamically. All these points are important. That's why we believe reasoning models like DeepSeek and Llama Nemotron will be key elements of an agentic system, right? And this is the slide I was talking about. So we have released the methodology we use to use, for example, a Llama or another open source model and make it a reasoning model. And here you can see we tested this for Llama 8 billion, for Llama 70 billion, and 405 billion, so Llama small to Llama large. And we sort of used different techniques like distillation, post-training, reinforcement learning, a couple of steps we did, and then package as a NIM in the end. And we were able to increase the intelligence of these models by order of magnitude. Right, so everybody could do that. So when there are new foundation models coming into the market, we can make them customizable and sort of reasoning. Yeah, so we use the framework called NEMO. It's a framework that allows you to do all these post-training, reinforcement learnings, and it's partially open source, right? And by the way, it can be switched on and off the reasoning. That's important. For those of you who want to try this open Llama Nemotron model, it's on build.nvidia.com, and it's leading accuracy, so it has similar accuracy as DeepSeek, but it's smaller. And remember, the smaller the model, the less energy you need and the less GPU compute you need, and the faster the model will respond, right? So small models is really important. And here you can also see that we use the API standards of OpenAI, so it's very easy to interact with these containers, with these NIMs. And that's the framework I was talking about. It's called NEMO, neural module it's called. So different elements that you can take jointly or just individually. For example, the three ones on the left-hand side, the curating, customizing, evaluating loop, that allows you to take a foundational model and customize and fine-tune with your own corporate data and language. Yeah, making a Llama model better understand financial analysis, balance sheet, yeah, or financial regulation. That's an example. So all this takes a lot of compute power because data need to be curated. That means tokenized. It need to be, the model need to be customized with different techniques which take a lot of compute. And then you need to have a consistent evaluation of the output, because customizing your model can also deteriorate the model quality. You can destroy your model or you can make it better. So you need to have an evaluator that quickly tells you in which metrics your model has been improved, right? And by the way, you also need the evaluation framework to see if new models are valuable for your organization. When there's a new Llama or DeepSeek coming, you need to be able, I think, to be able to have an opinion about this new model. Does it work better in that context or this context? How efficient is it? How much more quality does this model bring? Do I decide to use this model in production or not? Right? So evaluating these models is important. And it takes a lot of compute to evaluate models. Then comes the retriever. Obviously, retrieval augmented generation also takes a lot of compute power. You need to build these embeddings, re-rankings, vector search, right? Connecting all your data sets, your proprietary data sets to a model using RAG is quite compute intense. So that's why we build all these sort of modules, most of which are open source, so that people are able to build these cycle. We call it the data and AI flywheel, because agentic systems will never be static. They will always be in motion. There will be a lot of data collected on the way, a lot of customer feedback collected on the way. So you basically need to be able to not only run this as a process, but as a loop, right? There will always be more customization, building new RAG pipelines, evaluating the model and guardrailing the model, and eventually deploying as a NIM, and then keep going, right? And by the way, also the guardrailing project here that I see, Nemo Guardrails is an open source one, which helps you to build policies and guardrails around your open source models. It's a factor of compute, because the more policies you implement or guardrails, the slower your agent or model will become. So you need to think about, how can I make this more efficient? How can I execute policies on the runtime in a massively parallel way using accelerated computing, right? So the model quality and the model safety and security is directly connected to how much access you have to compute and how efficient you build your systems. So that's the data and AI flywheel. We have this as a blueprint. Blueprints is what we call the reference architectures. You can just download, get going, and build your own data and AI flywheel. And these reference architectures you can also modify, flip in and out models. So it's really a very open and breathing framework. And we are building more of these blueprints. Another one here, that's a corporate enterprise research and reporting blueprint that you can download, which allows you to synthesize hours of different material and data from different modalities in minutes. So it's an interactive tool where the agent has access to all this data, and you can flip in and out models and data very quickly, using obviously a reasoning model, using a RAG pipeline, right? And those are the building blocks of this blueprint, basically. It's the reasoning models, Llama, Nemotron. You could also use a DeepSeek. You can swap them in and out in 10 minutes in the NIMs, as I explained at the beginning. You need a very efficient retrieval augmented generation pipeline to connect your agents to data and to other agents. And then we have another open source tool that we released recently. It's called Agent Intelligence AIQ Toolkit, which helps you doing the following. To save time, reduce cost, and improve the business outcomes. So on the first one, it allows you to simplify the development of agentic systems, right? Downloading the blueprint, choosing the agents, connecting them, and also leveraging a lot of other frameworks that we have seen. A2A was mentioned and others. So it's not a replacement AIQ toolkit, but it's more like an expansion on what we already have, focusing on streamlining agentic workflows and optimizing them. Second is to reduce cost. So we can collect a lot of data while running these systems, telemetry data, that gives us the opportunity to optimize. So the agentic AI toolkits allows us to investigate where is a bottleneck, where can I optimize things, where can I replace models and change the workflows. So this is really for accelerating the agent response times, so that nobody wants to interact with a machine that is slow, right? You want the instant sort of response. Think about perplexity.ai, where you have a research report. It breaks down the task into subtasks, executes them very transparently, and within a few seconds or minutes you get a full research report that knowledge worker would have taken like 2 weeks to produce it. Yeah. So reducing cost, acceleration, and also the to evaluate these models, these agentic systems in terms of response accuracy is crucial in our industry, obviously, and also to be able to audit and trace back is important, to have the full transparency and to build AI governance frameworks around your agentic AI systems. So all these things, there are tools in that AIQ toolkit, and obviously it's an open source project, so we hope that more and more people support us in building that. And all these blueprints here that I have shown, there are even more. They are on the website, and it's not only NVIDIA blueprints, but also third-party providers help us build more and more blueprints. Because in the end, if you have a use case, you want to break it down to a workflow, then you can map it on a blueprint or several blueprints, and you are able to deploy in a few minutes or days your new agentic AI workflows. So it's a huge ecosystem that we are working with, foundation model providers, obviously, agent orchestration and management providers that we are working with, building these agentic systems, and on the blueprint side is the same. Some of these blueprints are from our teams, others are in collaboration with third-party providers. So think about the NVIDIA platform as a huge ecosystem, and a lot of other companies working with us. Jensen sometimes explains that NVIDIA is the only AI company that works with all the other AI companies. So think about it as a huge open platform and ecosystem that we are working on, and I invite everyone to contribute and collaborate on this one. In the last few seconds, maybe just a few examples of leading banks in Europe and the US already implementing this. We have the German Finanzinformatik running agentic multi-agent applications on premises. They serve 50 million customers, and it's interesting that they have built this completely on premises using the AI factory concept. BNP is building a sort of hybrid approach. They have on-prem GPU and public GPU in the public cloud, and they have built a sort of AI factory in a hybrid fashion. And some other companies are introducing these NIMs and these blueprints as we speak today. Yet another company has decided to build an AI factory on-prem, and they use it both for exploration of AI use cases and production and scaling of those AI use cases, because a lot of people, they struggle to bring their proof of concept into production at scale. So that's one inhibitor, and those AI enterprise stacks allow you to do that. And the other thing is, when you have like 600 opportunities, as this bank has identified, you need to work with a full data set, and you need to be able to fail fast, fail forward, to identify in a few months if those 600 opportunities are real opportunities or if they are just, you know, imaginary use cases. Yeah? And again, it's super important to have an efficient compute platform to quickly test, to fail fast, fail forward, build these AI and data flywheels, because things are very much in motion. Last but not least, this is a nice example of a coding co-pilot, if you want, using open source tools. So Temenos built a system that lets you interact by conversation with your core banking system. Chat to your database is the use case. And what's behind it? It's text-to-SQL NIMs, yeah, using open source models. Building this in a few months. We helped the team build that. So just a wrap-up slide, few takeaways. We are in the middle of industrial revolution powered by AI factories, and we are entering the token economy, thinking about AI factories as input of energy and compute, and the output is tokens or unit of intelligence. And this is how we should set up our AI factories, be it in the public cloud, sovereign cloud, or on-prem, right? Open source reasoning models at scale is really good because you have the full control of your models, because you define where to host them, where to run them. That's a high level of governance and sovereignty. And they are the engine of agentic AI, reasoning models, obviously, because they can do these specific agentic AI tasks. You need full stack accelerated computing platform, obviously, to run all these AI tools, enabling agentic AI. Just the compute is not enough. All the upper layers are also equally important, like blueprints, frameworks, inference microservices. That's what we mean by full stack platform, because AI is a full stack problem. And I have shown the blueprints and agentic AI frameworks, so leveraging the open source community, building these workflow optimizations, that's really important. It's a team sport, AI, right? So we need to work together on this. And we have seen some leading banks already jumped on board on the bandwagon, and they are building out their agentic AI systems. So it's not a buzzword, it's real. Thanks for your attention.